Can you guys see my screen? Can you guys see my screen? Hello. Okay, okay, perfect. So I hope you guys have revised uh, your C slash C plus plus. I mean, yeah. So let's start. Let's get started with the first problem. Give me a second. 1 minute. Yeah. Let's get started with the first problem. So the first problem is actually pretty easy. Just I'll give you guys 2 minutes to read it, but I'll read it first. So the algorithm is basically if they give us a number n, and if it's even, we divide it by 2, and if it's odd, we just multiply it by 3 and add 1. And we just repeat this until we reach 1. They just tell us we reach 1, so we just have to output the sequence of the numbers. So I mean, this is pretty self-explanatory, so let me just go through it though for people who are kind of confused. So 3 is odd, so it becomes 3 into 3 plus 1, right? So 10, but 10 is even, so it gets divided by 2, and it becomes 5. So I think this problem is pretty easy, so this would be a good way to start. So for people who are confused on why I'm using online compiler, see, my I usually code on VS Code, but it has a lot of already written code, and I feel like it'll confuse you guys. So I think I'll code everything from scratch here so that it's easier for you guys. So for now, this is for people who are confused. Okay, let me just erase this. Hello world. So this is pretty simple. I just write the code here, and if I have any input, I just input it here and I just run it. It's that simple. So for the first question, let's just code it up. So let me just declare n. So when I use the word declare, I'm basically telling the compiler that there's a variable called n, which is an integer. That's all. And I could also do something called initializing. Initializing would be basically be declaring it and assigning it a value. And what is assigning? Assigning it is basically when I tell the compiler that uh, this variable, this variable's value is 0. That's it. That's basically what assigning is for now. So yeah, so let's start with our algorithm. So you guys would be familiar with the while loop, I'm assuming, right? Wait, before I do that, let me just take input. In C++, this is how you take input. That's it. It's as simple as that. And yeah, so so how a while loop works is there's a condition here, and I basically, let's assume print hello world. So and let's just say n is 5 or something, and n minus minus, and while n is greater than 0. So what this while loop it does is basically until this condition is not satisfied, it keeps running this. So when we input, let's just if we input n is equals to 5, it's going to print hello world, then n is going to be decreased to 4, then it's again going to print hello world, it's going to be decreased to 3, and so on until it hits 0. Then this while loop will terminate. So let's just see if that works. Okay, yeah, I missed a semicolon. Happens to the best of us. So yeah, so this I printed it 5 times. It's like, yeah, that's how while loop works. I'm pretty sure you guys would be familiar with for loops and while loops. I just want to make it a little beginner friendly. So now that they've told us that it terminates at 1, so we just want to make sure while n is not equals to 1, because as soon as it hits 1, we want to terminate. So now we have two things. Inside the algorithm, we have two things to do: if it's odd, if it's even. So let's just check. So some of you might not be familiar with this modulo operator. So what this does is n%2. So basically, here it just finds the how do I describe it? When I divide n by 2, it just finds the remainder part. So let's just say n is 5. If n is equals to 5, and then this would return 1. And if n is equals to 4, then this would return 0. I mean, if you're confused, you'll just understand it after I finish coding this. So now this condition would be if n is odd. So if n is odd, we just multiply it by 3 and add 1, right? So n is equals to uh, n, n plus 1. So we're just multiplying it by 3 and adding 1 and assigning it. That's done. Or else n is equals to n by 2. It's pretty simple. And they also told us to print everything we are doing. So first, first let me just print out the uh, n itself, because they want us to print the first number we get. So then after this we do this operation, we print again. Yeah, so this should work. Let's give the same thing they did. Okay, let's give 3. Okay, so you can see how it printed exactly the thing. So now I just need to save this. So how submitting in CSES is kind of weird. You just submit it through a file. So I choose, yeah, and C++. So let's see if we are correct. Did I mess up? I think I didn't save the file. Let me just cross check. Okay, let me just submit it again. Should work. This is weird. Okay, it's assumed it's not getting saved. Okay, give me a second, guys. Let me just figure this out. Should work now. Yep. Okay, fine. Yeah. So okay. So we didn't. Uh, Somehow we messed up somewhere apparently. So, anyways, the good thing about CSES is you can see the test cases. So let's see, where did we mess up? Time limit exceeded when. Okay. So this is like the standard error. You will face this a lot uh, when you start practicing problems. I'll explain what that error is. I think that's it. I think this is what the most errors are. So there's something called. I'm assuming that's the error. So let me just switch it and just confirm if that's the error. Wait. Yep. So what happened is there's something. So in C++, there's different types of data types, right? There's int. There's there's int. There's long int. There's float. I mean, there's multiple types. So I think the first step you should do is you should figure out what's the range of these numbers. So float, let's forget about float for now. Float doesn't matter that much. So the range of int is I think around 10 power 9. So if it goes above 10 power 9, there's something called overflow. So it becomes like negative 10 power 9. I don't want to go into the specifics for now, but just think that if you're using an integer, and if your number, there's a chance that this could go about n could go about 10 power 9, right? Then our program would completely mess up. So that's why I changed the integer to long int. So the range of this is 10 power 18, like a lot more, 64 bits. So this is very so if you use this is the like called the overflow error, and you'll face this a lot of times. So just try to keep it in mind. So if your program messes up, this should be the first thing that should come into your head. So we're done with the first problem after some problems, but yeah, let's go to the second one. Okay, so you're given numbers between from 1 to n except one number, and your task is to find that missing number. So let's say they give 5, n as 5, they give you 4 numbers, and in those, one number between 1 to 5 would be missing. So for the first question I didn't do this, but from now onwards we're going to follow this one way to solve every problem. We're going to first try to think of a way to do it, then have a proper pseudocode in our head, or write it down anywhere, anything works, and then only code it. So we should have a working algorithm in our head before we actually go about coding it. So does anyone have any ideas on how we would approach this? I'm sure some of you, I've told you guys to try out the first 5 problems, right? It's fine if you're wrong. I mean, you're probably like this. I'm sure you get, some of you have an idea. Just it's better if you guys, yeah. Can you? I mean, it's hard for me to read chat. So can you guys unmute? I'm not looking at the meet. I'm looking at the CSES problem set. I mean, if you're not fine with unmuting, I guess I would read chat. Okay, sort it and whether check whether the index while looping is same as the number. Yeah, that works. And find the sum of first and number and subtract given sum of using the math formula. Yeah, both. I mean, both work. Both are pretty good ways to do it. Uh, I haven't. I mean, okay, fine. I'll choose the math one. Math one is actually pretty cool. Even the sorting one is definitely correct. Both are correct here. It doesn't matter. At the end, you just want to get the solution. You don't really care about. You don't care that much right now about which is more accurate or whatever. So we have end, right? And so I'm going to. I mean, I just yeah. I'll just declare an array here of size n. So the array is called a, and n is the size. This is kind of a bad thing to do, but we'll find out later on why this is bad and what should we do instead. For now, let's yeah. I'm also going to declare a sum variable to keep track of all the numbers. So I input all the numbers, and then I add it to sum. So now sum has every number except that one specific number. So now how do we find the other number? We just so before we do that, we know that there'll be every number. If like let's assume, what's the sum of every number from 1 to n? That's, I'm pretty sure you guys would have encountered this in JE. That's basically n into n plus 1 by 2, right? So this is supposed to be the sum. I mean, this is the sum if you add every number from 1 to n. But there's a number missing, and we know the sum if that number is missing. So to find that number, we can just do this minus the sum variable, right? That should give us the number, because this sum thing has that hidden number as well. So we can easily do that. We can write sum is equals to this. Let's just put that in brackets so that we don't, yeah, minus sum. So now that sum has our hidden number. So we just output it. So this should work. Anyways, let me just copy paste. Okay. What did I do? Mess up. Yeah, one classic mistake. I didn't realize that the amount of the number of numbers they're giving is n minus 1. So this should work. Yeah, so it worked. I mean, n minus 1 numbers, add them into a sum and just subtract it from the total sum 1 to n formula and just output it. It's as simple as that. By the way, if any of you have any doubts, don't hesitate to ask. Even if you look stupid, this is your chance to learn. So you'll struggle later on because these problems are pretty easy compared to what we're going to do next. Oh, wait. Oh, shit. I forgot to update it. Yeah. Yeah, this should. Wrong answer again. Did I mess up somewhere? Let's just see the test cases. Okay. So when your output is negative numbers, you can tell that, okay, I overflowed somewhere, right? So let's just look at the constraints again to figure out, did we mess up somewhere? So this should cover it. We use long end. Hmm. So our worst case scenario, this our sum, the highest our sum can be is around n into n plus 1 by 2, right? It'll miss some number. Let's assume that's 1 or something. So that should be 10 power 5 into 10 power 5 by 2 plus 1 by 2. That should be around 10 power 10. And that should come under long int range. So I don't know where exactly I'm messing up. What? Okay. For some reason we're way off what we're supposed to output. Oh. Um, hmm, I mean, it's kind of hilarious why I can't figure out the problem here, but let's do the other way for now. I'll call it. If you any of you have an idea of why the program's messing up, please let me know, because I have no clue why. I genuinely have no clue why it's overflowing. Because we're under everything. Yeah, it should be covered. Uh, yeah, it should be covered. Okay, let's scrap it. Let's go through the first tools. Yeah. I should be long int. That shouldn't matter because n range is only 10 power 5. N range is only 10 power 5 and that's covered under int. And when you're adding AI is long int, so that should be covered. But for you, I will change it to long int. Oh, you mean n? N also I don't think should matter, but let's just do that for, yeah. It's a good session. I mean, we're gonna figure out. It'll be funny if this would work. Okay, 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 nice. Let's. Is it N or is it I? Which one of them messed up here? So N here is only being used to define the array size and go loop through it. So I don't think it should be N. Yeah, it should be N because I used that formula here. My bad, you guys are right. I completely forgot I used N here. It overflowed here, guys. So when I used that, it was not about I, it was about N. So this should work as well. I didn't look at, yeah. Here is getting overflowed because N range is 10 power 5, right? 10 power 10 would overflow. I hope you guys understood. It's a, yeah, classic mistake. Anyways, now let's go to the third question. Okay, so this is a string problem. You are given characters A, C, G, T, and your task is to find the longest repetition in the sequence. So basically, what they're asking is, they'll give you a string of random characters like this. You're supposed to find the maximum, the maximum length where the characters are repeated. Like here, it's G G G. So here, this is repeated, so you output three. If this wasn't there, then you would T T would be there, so you would output two, something like that. So for this, you would need to know what something called strings. Uh, yeah, and before I tell you guys about strings also, there were two things I do before every time I code. So this would be something I change. 1 minute. So this is called the STL library. So for those who are not familiar with what include does is, include it basically includes libraries. Okay, libraries have some functions and data structures which are predefined, so they make it very convenient for us to use. You'll find out why. And uh, and this is just using namespace std is basically, if you want to sort something, let's say you want to sort, you would do something like this, but namespace std lets us ignore this completely. So it automatically puts the std prefix behind it. It's too we'll figure that out later. It's, yeah, we don't need to worry about that now. So we have the string, right? Yep. So this, what a string is, I'm sure you guys would have been, if you had seen your first course, you would have something called character array, right? It's very similar to this. In Python also, I mean Python, forget about Python for now. And yeah, in C it would be very similar to character array. So so you could, but the convenient part is you can just input it directly like this. So when you, since the input is one long stream of characters, you can just input it through a string, and this input ends when it encounters a new line character. Basically, if let's assume the input is and okay, that's very random, but it won't add both of these lines to the string. It will only add the first line, because after this is a new line character, because it'll send the cursor to the next line. So let's just ch- you know I'll just run it and show it to you guys. Yeah, so you see how it's ignoring this, because I could, if I initialize one more string variable and do it and input it, then it would show this. But yeah, so basically this is how strings are. And to iterate, and you can, yeah, after you get the string, you can there's one more thing called s dot length, I mean string dot length. So you can find the length using one predefined function. So this gives you the length of the string. It's very convenient again. So here, if you write, yeah, here n would be 6, right? Because 6 characters are there. So this lets us easily iterate through the string. So now I hope you guys are familiar with for loops, right? I'm sure you guys are. So again, for those who aren't, I'll just brief through it. This is where I initialize, and I'm sure I went through for loops last last code, but I forgot to explain. So I'm initializing some character. This is like the general, you see most for loops would look like this. And so it would be initialized at 0, and this is like the while loop condition. It will keep looping until it hits this condition, and this is like the increment after every single thing. It's like a more customizable file loop, you could say. So now let's just iterate to this. So before I code, I said we have to figure out the pseudocode in our head, right? So we have a string. So how do we figure out what's the longest sequence? So do any of you guys have any idea? There should be some simple way, right? Anyone? Any ideas? Okay, it's fine. Yeah, fine. I'll explain it. So, our what's the best way to do this? So we could do this, right? We could have two variables. one variable, yeah, this is, I think I can write here, yeah, this works. Yeah, so we have two variables, right? One variable will be count. It'll be initialized at 0. I'll explain what count is for. And one more variable will be the last character you've seen. Let's just say last. Ignore my handwriting, guys. This is the first time I'm doing this. So let's just say we're iterating through this, right? So let's initialize our last character with some random thing. Which is not part of the, yeah, and initialize our count thing with 0. So when we're iterating through this loop, iterating through this string, we'll go through a. So is our last character a? It's not a because it's the first character we've seen. So we'll reset the last character to a and we'll increase count by 1. And now let's go through t. The last character would be a, right? Since a is not equal to t, we would reset. We would reset the counter and we would increase it again because we found one t, right? And now last character seen would be t. And now let's go through the second t. So that we would increase now our before we now our c becomes 2, right? Because we've gone through two t's consecutively. Since our last character is equals to the current character, we would assume that okay, fine, we can increase the count variable. So, and we're not going to change our count variable. So we can go through this. And now we go to C, it gets reset again because our last character is not equal to our current character. For those who didn't understand, I'll just code it down and explain it to you guys again. But I hope some of you at least get what I'm talking about. So now, like I said, I'll initialize 3 variables actually, not just 2. Count is 1 and answer is 1. And like I said, character, last character. Let's just since all of them are capitals, let's just say this is like 0 or something. So give me a second, guys. All right, I'm back. So where was I? Yeah, so we're defining 3 variables. Count is to just figure out how many of the same characters we've encountered till now. Answer is we'll go get to answer later. And last character is what is the last character? I'm initializing it at like some random character which is not part of the alphabets because I could just so that the first character won't be match with the initialized last character. So now while we're going through the loop, we have 2 conditions, right? If the character si is equals to last character, then we do something, else we do something. And string is basically, for those who don't know what a string does, it's basically like an array, except like it's basically like an array of characters. It's just more convenient. That's pretty much it. It's like a character array itself, but you have a lot more customizable functions you can use on it. And it's not a headache like character array. I hate that fucking thing. Okay. So if our current thing matches with the last character, we just increment c, right? It's as simple as that. And if it doesn't, we just make it 1 because our 1 minute. We first reset our last character to whatever this character is because we encoded this character and this is the latest character we've encountered. Instead of last character, I think I should name this latest. That would make sense. Yeah. So since the new character we've encountered is the latest character we've encountered, so that would be reset and reassigned, and our counter will be reset to 1 because this character we've encoded it once, which is in just now. And you might ask, what is this answer for? Answer is basically like we're not sure when we'll find our, our maximum, most, biggest C, right? So we always check for it. So every time we're about to reset, every time before we reset, we always just do answer is equals to max of C comma answer. So this is a function which exists in this STL library. Again, very convenient. So it's you can easily tell what it does. You give it two numbers and it just returns the max of those numbers. So anytime if C exceeds answer, we just give it, like we just reassign answer to that C, because we want to see the what's the maximum, the maximum C can become. And it's as simple as that. And just in case, sometimes we might let's say the input is like a what are the characters? A C G T, yeah, A C G T T T. So this else thing is called every time the latest character doesn't match the, the current character. But this here it wouldn't exactly work. I'll explain why. First, let's just output answer, because this should work, right? Because we're always changing answer if it becomes greater than C, and yeah, should work. And the answer for this should be 5, right? Since this is, it's pretty simple to see why it's 5. So we'll run it. Oh shit, why is it 1? Because we don't. Now if you output, let's just output C, because debugging is a very good skill to learn, because your code is not always right. You guys just saw how many times I fucked up, like the first two questions itself, right? It's like, yeah. Anyways, let's just output C to see, like, it's to see if C should be 5 after this thing. That's for sure, because it's always equals to latest character, and we just keep increasing it. Yeah, so it is 5. So what our mistake was we only changed answer when it was when SI is not equals to, like, when the string character was not equals to the latest character. So here it never encounters that if all the the last couple characters are the same. So let's just write, add one more line, which is basically just again doing, just in case, right? Yeah, this should work. So anyways, yeah, so let's just test it for this input. Yep, it works. So let's just submit it. Hmm. Yeah, first time we got it, I think on first try, hype. So we're done with 3 problems. Let's just, yeah, I guess we'll find the slightly harder problems now onwards. You're given an array of, so let me just read the statement. You're given an array of n integers. You want to modify the array such that it's increasing and basically every element should be, it's in sorted, non-decreasing order basically. Every element is at least as large as the previous element. On each move, you may increase the value of any element by 1. What is the minimum number of moves required? So, okay. So let's just, so before you try to think of any question, it's always recommended to look at the sample cases, because there are a couple of times where you read the question wrong and get yourself confused, or just not be, you don't understand the question itself. So let's just look at those sample cases to make sure what we've read, what we've understood is actually correct or wrong. So 32517 is our array. So okay, yeah, so 32517 is our array, and we want to our goal is to add numbers to each, add 1 to each element until it becomes in a sorted order. What's a sorted order? So sorted order is basically, let's assume the array elements are A, B, C, D, E, F. So sorted order basically says that it's A is less than or equal to B, B is less than or equal to C, C is less than or equal to D, D is less than or equal to C, E, and E is less than or equal to F. Basically, it's in not decreasing order or increasing order, you could say. Yeah, so this element is guaranteed to be less than this element is guaranteed to be less than this element, and yeah, it's basically that. So you have 3 to 1 5 1 7, right? So how they said with 5 moves you can make it sorted order. Let's see how that happens. So 3 2 uh 5 1 7. Holy shit, my handwriting is bad, but I hope you guys can understand. If you don't understand, please do please don't hesitate to ask in chat, or just unmute yourself, anything works. Anyways, so five moves, right? So let's just say, so where is this this condition not happening here? So is 3 less than 2 less than or equal to 2? No, 3 is greater than 2. So we have to increase 2, I guess. We have to increase 2 or decrease 3 to make this condition applicable, right? So let's keep going. 2 is less than 5, yeah, that's correct. 2 is less than 5. 5 is less than 1, nope. 5 is greater than 1, and 1 is less than 7. So these two numbers, so here we either, to make 3 less than or equal to 2, either increase 2 or decrease 3, and we can't decrease any values here, so we just increase values. So let's say we increase values. 3 is we increase this by, we add 1 to it, so 3 3 5. So this part of the array is basically incorrect, like in sorted value. So but if this one still remains, so how do we make one greater than or equal to 5? We just add 4 to it, right? It becomes 5. So now, yeah, this works. So we added 1 here and we added 4 here. So 5 moves. So it makes sense. Our logic is correct, and yeah. So do you guys have any ideas on how we would solve this? I hope you guys. If you guys didn't understand the sample case explanation, don't don't hesitate to ask me again. So let me know if you guys have any ideas on how to solve this. It's actually pretty simple. Just try to think of one guaranteed way in which we can 100% make sure it's sorted. Yeah, sorted. Anyone, guys? Okay, we got two responses. Add the difference of elements to the step count. I mean, is add the difference of the elements to the step count. So let's say we're iterating here. Would you let me give you a test case where that would be kind of wrong. Let's just go to the second one. Yeah. So you said add the difference of the elements to the step count, right? So if it's 1, 2, and 3, this is in solid order. But if you add, you can do this like this is basically zero moves, right? Zero moves, and it's already in sorted order. So you would be adding 1 and 1. Your answer would be 2. You're pretty close, but you're not exactly there. And let's look at the other one. Iterate through the array, and if inter current index is greater than the inter previous index, add the difference to the answer variable. Smaller. Okay, fine. Yep. Difference of only if it needs to be sorted. I understand what you mean, Danya. I hope I pronounced your name right. But try to have a more algorithmic way to answer. Like give me an if statement and condition inside which, and with only then you would add some specific things. Like give me a proper condition based thing. Like how Rijul answered. Like he said if int at correct index is greater than, yeah, that makes sense, right? You can read up and code it up pretty fast. Like try to give me answers like that. But yeah, nice try. uh, Rijul's answer actually does make sense. Add the difference to an answer variable. Yeah, that's pretty correct. And let's see, Callisto's add the difference of elements plus one. If why the plus one? I'm kind of confused. Why can't you just add the difference of the elements? Because it's not strictly increasing. The numbers can be equal. Let's say yeah. Let's say 1 minute. Yeah, let's say it's 2 and 1. So according to you, the answer would be 2 minus 1 plus 1. Answer would be 2, right? But you can only do this in one move. Just make it 2 2. 2 2 works. So that plus 1 is not necessary, I think. Yeah, yeah, that's fine. Yeah, yeah. I assumed you thought that. Yeah, so you guys got the answer. That's basically how you do it. It's pretty simple. So let's just iterate through the array. Let me code it up real quick. So we have just look at the just looking at the input. Let me just clear this up. So in 10. Guys, I would recommend you, to use VS Code or whatever IDEs. Don't use online compiler. I'm just using this just to show you guys. It's not fun at all. Yeah. Anyways, yeah. So we're while iterating, let's just I'm changing I to be initialized at 1. I'll explain why. And let's just also initialize our answer variable at 0. So wait. First, let's just take the entire input. Yeah, so we have the entire array now. So we're just going to iterate from I is equals to 1, I is equals to 1. So we're basically just if ai minus 1 is greater than or equal to ai, right? Yeah, 1 minute. Yeah, if ai minus 1 is greater than. So this is when we don't want, we have to increase AI, right? So we just do AI answer plus. This is basically like a short form, you could say. I'm not going to get into the specifics, but when I say, let's just say I write AI answer plus equals to C. That's basically, that's basically the exact same as answer is equal to answer plus C. This is just a shorter way to write it and it's more convenient. So if you guys from now onwards, if you see this is what I basically mean. Okay. So a answer plus 1 minus yeah. And there's also one more thing we have to do, because we also have to increase AI to AI minus 1. Since we're increasing AI, let's just update it, right? Because this might let me give a test case where this is important. Okay, 5 1. This is, yeah. Let's say we have 5 1 3. So if we don't update it, let's just say we don't update it, our algorithm would just add 4 to this, and add 4 to the answer and just continue, and it would check afterwards. It would check again, but this time it would still be 1, right? And it would assume that, oh shit, it's still 1 less than or equal to 3, so we don't need to add anything, and it would just terminate. So our answer would actually be 4 when it should be not, when it should be something like 6 or something. So we have to update it. So after we update it, after we update it, when we're iterating through 3, it would be 5 5 3. Then we would know that we have to increase 3 to 5. So then our answer would be 4 plus 2 6. Yeah. I'll work on my handwriting by the next time, in the next session, guys. Please, yeah, please don't mind. Anyways, yeah, I've updated it, and now I increase the answer, and that should work. So output answer. Let's just run this case. The reason I started I at 1 is because if I started at 0, let's assume I started at 0, then the if statement would compare a array of -1 greater than array of 1. Array of 0. We both know that, we all know that the indices start at 0, right? Like array indices start at 0 all the way to n-1. So this would basically, it would probably be like segmentation fault, I guess. No, actually I'm not sure, but it would lead up to an error because we haven't defined that memory. So I don't know what exactly the compiler would come up with, but it's not a good idea to try finding out what array of -1 leads to. So that's why I initialized it 1, and it starts with A0 greater than A1 and keeps going. So, and output is 5, which is correct. Okay, let's just submit it. Yeah, it accepted. So hype. Anyways, yeah, let's look at the next question. Permutations. Sounds good. A permutation of integers 1 to n is called beautiful if there are no adjacent elements whose difference is 1. Given n, construct a beautiful permutation if such a permutation exists. So what they're asking, before I go explain what the question means, let me just tell you guys something you'll encounter a lot of times. So there's something called permutation of numbers. So what's a permutation of numbers? Like permutation of n numbers. Yeah. So what a permutation of n numbers is basically, we have let me clear it. Let me just, I'm using this as my fucking notepad or whatever. Yeah. So a permutation of n numbers would basically be like 1, 2, 3, 4, 5, 6. Let's just say n is equals to 5, right? Permutation of 5. So what a permutation of 5 numbers would guarantee is there are a total of 5 numbers. It guarantees that, first of all, and it also guarantees that there's exactly 1, 1, 1, 2, 1, 3, and 1, 4, and 1, 5. Like basically, those are the only two things it guarantees. So more examples of permutation would basically be 5, 3, 1, 2, and 4. So okay, that's not 4. Yeah. So fuck. Yeah. Anyways, don't use online compiler, guys. But yeah, so it basically, like any order, at the end the array should have 5 numbers, 1, 2, 3, 4, 5, and yeah, that's it. That's basically it. So if a permutation of n numbers would have 1, 2, 3 dot 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 n, but we don't know in which order they are. That's basically what permutations are. Now let's go back to reading the question. So a permutation of n integers is called beautiful if there are no adjacent elements whose difference is 1. Given n, construct a beautiful permutation if such a permutation exists. So they want us to construct an array, and basically they give us some random n, which is from 1 to 10 power 6, and they want us to construct a array of n integers where, like I said, it should follow the permutation rules, but it should follow one more rule on top of that. You have to construct it in such a way that the adjacent elements on, the difference is not 1. So basically you should not be like let's say for this 5 itself, it should not be like 3, 2, 4, 1, 5. We can say that here the elements are, the difference is 1, right? They said whose difference should not be 1. So the difference is 1 here, so this would be invalid. This would be wrong. So they want us to output something like this. Here the difference, you can clearly say that it's 2, 3, 2, 2. Like you can clearly say that the difference is not 1. And for 3, they said output no solution if it doesn't exist. So let's think logically. So for what all we can guarantee that there's no solution. So n is 1. So 1 has a solution, right? Because 1 is just, if you just input 1, output 1, that's it. Like array of size 1 would have only one number, which is 1. It doesn't have any, adjacent elements. So 1 is kind of like an edge case. And 2, if you input 2, there are 2 permutations of 2. It's basically 1 or 2, or, okay. Or 2 or 1. So these are the 2 permutations of size 2, right? These are the only 2 order you can get. Yeah. So the adjacent elements are obviously, the difference is 1. So 2 also would have no solution. And now let's look at 3. So the permutations of 3 would be 1, 2, and 3. Okay, bro. Yeah. And 1, 3, 2. I think you guys get it, right? 2, 1, 3. 2, 1, 3, and 2, 3, 1, and like 6, I guess. Yeah. 3, 2, 1, and 3, 1, 2. So these are the 6 permutations of, size 3. Can you look at all of them and tell that there's obviously no like there's no permutation where all the adjacent elements are greater than 1, because you can tell the among all these three numbers there's only two numbers which have a difference of greater than or equal to 2, which is 1 and 3. So 1 and 3 are the only two numbers, if they're adjacent, their difference is greater than 1, I mean. Yeah. So it's 2. All the other, 1, 2, 2, 3, all the other ones are 1, which is not what we want. So here we have two adjacencies, right? We can only use that 1 3 adjacency once. After that we have to keep 2 beside either 1 or 3, and it would lead to no solution. So I hope you guys understood. My explanation is kind of bad, but yeah, 3 has no solution, and 4 you can obviously tell there is a solution. Let me just show you guys the solution. 2 4 1 3 works, right? uh, the difference here is 2, the difference here is 3, and the difference here is 2. So have you guys figured out a solution for this? You just have to basically generate an array where, yeah, it follows the properties I said. I'm sure some of you would have come up with something, right? Just try to come up with anything. It's a pretty cool problem. Print, okay. Print even numbers first and then odd numbers, and print all odd indices then all even. Yeah, you guys, yeah, both solutions work. Yeah, you guys, all of you have come up with the correct solution. I'm sure there's other ways to do it, but that's what even I thought of. I thought of printing either the odd numbers first and then the even numbers, or the other way around, whatever. So let's just implement that real quick, since this seems to be simple for you guys. Okay, 9 and 10. So, oh yeah, before I implement this, let me just show you guys a cool data structure called vectors. It makes it way more convenient. So vectors are basically, uh, before I just do vectors are so how you vectors are basically like dynamic arrays. They're they have they're basically arrays, but literally better. Like arrays have almost nothing above vectors. You would always mostly use a vector over an array. It's like the cool vector, I mean cool array. So this is how you define a vector. Here is what you initialize. Here is what you want the data type to be. Like the difference would be, let's assume int a n, right? So this would be like how you would define a vector. And if you want to define the size, you can define it in the brackets. But I won't define the size now. I'll show you why why exactly they're dynamic. Basically, you can remove and add elements however you want. And this is the thing I was talking about. If you don't, you can if you using namespace std, you can basically not type this. It's a pain in the ass, right? It's more convenient. I would not take, yeah, for DS and CP, this is just follow this. Yeah, you do it. Nothing wrong with it. So basically, vectors are arrays, but you can add elements and not remove elements. So I'll show you how to add elements. So you get I'll first add all the even elements and then the odd elements, right? So do you guys understand why I'm iterating like this? I initialized it at 2. We know that it's 1 to n, right? So all the even numbers would be 2 4 6 dot 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 dot. So I is equals to 2 is the first thing, uh, yeah, the first even number you will find in the array, and you keep increasing it by 2, and one more condition, that it should be less than or equal to n. My bad. Yeah, less than or equal to n. So this should work. So if you do v dot pushback, yeah. So here what v dot pushback is, this is basically just adding I to the back of the vector. So now let's just wait. I didn't initialize n. Let me just show you how v works. I'll just output v. I'll just output what I've seen in v. I'm using one more function which you guys are not familiar with. I'll explain that as well. But let me just show you a cool lesson on what vectors exactly are. Yeah, so this should let's just give it like 6. So our expected output should be 2 4 6, right? Does that actually happen? since we're only inputting the even numbers. Yeah, it does happen. So how it works is it just appends I to the back of the array. I'm pretty sure people who are familiar with Python should be like, you must have seen functions related to this. C guys would not have probably, but yeah. So you just uh, you just add I to the end of the array. It's pretty simple. It's just you'll understand what it means. And one more thing I've used is v dot size function. You can tell by the name of what it means. It basically just gives you returns the value of how many elements are in the array, vector. It makes it way more convenient. Since it's not like arrays, right? Arrays you just fix the value when you initialize them. So you would always know their size. But vectors you wouldn't, because you can always add and remove elements, so they could keep changing. So this is a way to iterate through all the elements of a vector. So now that we've gotten out of the way, let's just, since we've added all the even elements, let's just also add all the odd elements. I is equals to I is equals to 1. Yeah, I plus equals to 2. The reason I'm writing I plus equals to 2, so that if I write I plus plus, it would go 2, 3, 4, 5, 6, right? We want to skip over all the odd elements here and all the even elements here. That's why this helps us. I'm increasing I twice after every iteration. So now we just do v dot push back I. So this should work. Uh, yeah, now let's just, I don't know why I removed that outputting all the elements, but let me just type it back in. V dot size. For those who are confused with what endl means, is basically just this. You must have seen this in C, right? It's pretty much the same except one small difference which doesn't matter, no? Yeah, so anyways, yeah, I forgot to add the edge conditions, right? If n is 2 or 3, we should not 2 or n is equals to 3. We output no solution. Yep. Yeah. So, but we wanted to ignore all the code after this. So how do you do that? We just give a return. We basically terminate the program here itself. Pretty convenient. So this should work. So let's just give 5. Let's just give it 5. So according to us, it should be 2 4. I mean 2 4 1 3 5. Yeah, perfect. And if you give 2, it should not output anything after no solution. Yep, perfect. It works. So wait, before I submit it, just in case, let's try giving 1. It's always recommended to just test some things before you submit it by yourself, because sometimes 1 can fuck you over, and it works here, so good, I guess. So let's just submit it. Okay. Okay, it works. Let's just ignore warnings. It's just a warning, right? Big deal. I'm joking, guys. Don't ignore warnings. Anyways, let's look at. Okay, this problem is kinda tricky, I guess. Okay, so what the question is, basically there's a number spiral of an infinite grid whose upper square has number 1, and here are the first 5 layers of the spiral. So how it goes is, you can see it's going like this, right? It's like, how do I explain it? It's basically adding a layer of layer after. Yeah, it keeps adding a layer. It could go like something like this. Your task is to find out the number in row y and column x. So here are some test cases. Always look at the test cases, like I said. Input 3. Okay, so we have something called so they're asking us 3 questions basically. T is 3 means they're asking us 3 different questions. So in row y and column x, and input is in y comma x, right? Okay, so row 2 and column 3. So row 2 and column 3 is 8, right? We can see that. So output, we should output 8, and 1 comma 1 is obviously 1, so we output 1, and 4 comma 2 is 15. So fourth row and second column, 15. So this question is mostly about finding a pattern and trying to code it out. So I'm sure some of you would have seen a pattern here. So any ideas, guys? At least, like, let's try to figure out first. Let's start by figuring out what is the range of the answer. Like, let's say I give you some y and x, right? Can you tell, can you at least approximate the answer to me? Like, can you tell me, okay, it'll be between some number, and it'll be less than some number and greater than some number, not something like 0 and infinity. Like, let's keep it realistic. Like, if I tell you more, I'll give you the answer. So I'll see if you guys can figure it out. So can any of you figure it out? I'll give you 2 minutes to think, because this is not that easy also. Range is from 1 to n square. Okay, fine. What is n here? The input is y comma x. I Do you mean like the maximum of y comma x or something? Max of x comma y. Okay, yeah, fine. That makes sense. It will always be less than or equal to x comma y. Is that always true? XY, does that mean x into y? Callisto. That's. I mean, let's look at the test cases. Here, y comma x is 2 comma 3, right? If you multiply them, it's 6, but the answer is 8. And Rijul, you're actually pretty right. Like, can you be a little more specific? You're correct. It's between 1 and n square, but I'm looking for something little bit more specific. Like, can you guys see the property of the latest? Like, let's just say this is like, you see this L shape, right? Can you tell me what this L shape, like, what's the range of this L shape of each number? That L shape is basically that L shape is what you guys are what you're talking about, right? The max of x comma y. Can we use finding area and add something? Area. Okay, I haven't thought about area. Let's see. I don't think area would come into play here. I might be wrong, but I don't see area being useful here. But I don't think so. But what I'm saying is, just try to see which L are you on? Yeah, which reverse L shape are you on? Is there a fast way to see which reverse L shape are you on? Like, let's say this is the first. Let's say this one is the first L shape. 2, 3, 4 is the second L shape. 9, 8, 7, 6, 5 is the third L shape. 10, 11. Do you see this L shape? Like, is there a fast way to figure out which L shape we're on? Yeah, max of it's max of x square y square. It's just max of x comma y, but square. Yeah, wait. Let me. Okay, like for 2 comma 3, if we find the inner square, we get 2 square to 4. Okay, 2 comma 3. 2, 4. Can you unmute and explain it? It's kind of confusing to read it on text. It's like, it'll be better to understand what you mean. Pranav. Yeah, I can hear you. It's fine. Hmm. Yeah. If you do it for 15, the inner square would still be 4, right? Huh. Okay, you mean like that. Okay, yeah, yeah, yeah. Yeah, 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 you pretty much figured it out. Yeah, nice. Yeah, yeah. Yeah, so basically, what he's trying to tell you guys, what he's trying to tell is basically, uh, we just look at the max of the column, row and the column. Here, let's say 2 comma 3. So we can tell 2 comma 3 would be on this L shape. That's what I was trying to tell you guys by L shape. Like the inner square would be for 2 comma 3 it would be this 987 and 65 L, right? The inner square would be 1 2 3 4, and for 4 comma 2 it would be the L I'm talking about would be 10 11 12 13 14 15 16 1, and the inner square would be like 1 2 3 4 5 6 7 8 9. So we know the answer is between n minus 1 whole square less than or n minus 1 square less than or equal to it's greater than n minus 1 square and it's less than n square. So that is the strict bound I was looking for. But you guys were pretty close, and one of you figured it out but didn't exactly get. But it's fine. That's more than what I was expecting. Good job, guys. So it's between n minus 1 square and n square. So how do we find out the exact answer? So for 4 comma 2 it's between 3 square and 4 square, 9 comma 16, but answer is 15. So how do we figure that out? It's just looking at the grid, and it's alternating like he said. You just have to look at the row and column and you have to figure it out. So this is like more about, I wouldn't say this is more like exactly the best problem. So I think I'll keep this as homework, like just come up with the like code this up, and I'll discuss this properly like maybe next section. I'll skip this one off. We pretty much figured out the how to do it, but it's just implementation. You have to figure out which row and which column you're on, and try to get the exact answer. It's not complicated, but I just don't want to do it right now, so maybe next time. So I'll just leave this here like this for now. Okay, two nights is also a problem. I think I'll give it for homework, but I'll just explain it to you guys. It's a pretty cool problem. Your task is to count for k is equals to 1 comma 2 comma dot 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 n the number of ways two knights can be placed on a k cross k chessboard so that they do not attack each other. So let's just take a 8 cross 8 chessboard. So it's pretty much finding patterns here again. I don't want to do this problem right now because it will take like half an hour maybe to explain everything properly. If you Google this, you'll see people using random formulas which don't make sense. That's because they come up with those formulas by figuring out a pattern. Let's just so since this is kind of like pattern based, I would I'll give this as homework as well. So you just try to get a good intuition of this question. Try to figure out like when you look at a question, you try to figure out any properties of the question. Like for example, let's look at the previous questions. Okay, no, I'll explain what that means later, but try to just have like some base for this question. Try to think about that question and try to come up with something. You don't have to come up with anything, but I might discuss this next session because it's just mostly formula based, I guess. It's a good question regardless. I'm not saying it's a bad question, but it's an interesting question. It's just too time take consuming for now since we're kind of running out of time. So two sets. Your task is to divide the numbers 1 to n into two sets of equal sum. So so if they give us a number n, again this is basically like a permutation, right? So you have an array of 1 2 dot 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 n, and you need to figure out if you can divide them into two complete separate sets such that the sum of one set is equal to the sum of the other set. And one another question is if this is possible or not. So if they want us to print out the one of these sets if it's possible, both the sets actually if it's possible, and print no if it's not possible. So before we go to printing the sets, is there a way, can we figure out if by just looking at n, can we figure out if it's possible or not? Do you guys have any ideas? Okay, someone sent the code for the previous question, and yeah, it does look correct. Yeah, it does look correct, Ritual. I'm not. Yeah, looks pretty accurate. Yeah, that. I think you guys can just refer to his solution, but you can minimize that code by just writing, finding the max of x comma y, like separate variable. You basically just wrote the same code twice, but it's still good job regardless. Sum of the numbers should be even if you want to divide it. That's correct. Yeah, that's exactly what I was looking for. Sum of numbers should be even if you want to divide it. So the formula is n into n plus 1 by 2, right? Like sum of 1 to n. So we want that would be the sum of the numbers. We want it to be divisible by 2 again. So in like to find this in like coding terms, how would you do it? You would do it like this, right? If n n star n plus 1 by 2, this should be, we want this to be even. This to be even. So we just do 2, right? So this, if it follows this condition, I mean this should be equal to 0. It should be even. So equal to is basically a comparison operator. I think I should have explained this before, like in the first few questions, but it just checks whether this is equal to the left side of the equal to symbol is equal to right side of the equal to symbol. It returns true if it's equal and false if it's not. And yeah, that's basically how if statements work. And so this is basically how we check. I'll just make it look a little nicer by just sending the 2 over to the other side. And n into n plus 1 should be divisible by 4. You guys understand why, right? Yeah. So wait, first let's just see if it's not divisible by by 4. So if it's not divisible by 4, we just obviously output no. So that's sorted. Return. Yeah, that's pretty simple. Done. So now we have to figure out how to divide it into 2 sets such that we can easily tell that if we want to divide it into 2 sets of equal sum, the sum should be sum should be n times n plus 1 times by 4, right? Because the 2 sets are equal and the sum is the same. So if you add up the 2 sets, your total sum should be n into n plus 1 by 2. So each set should be n into n plus 1 by 4. So we know that for one set, this is the required required sum. So is there a way to figure out how do we divide 1 to n into 2 sets such that each set is this sum, and obviously the other set also would be forced to become this sum itself? So do you guys have any ideas? It might seem hard, but it's actually not that hard. Okay. Yeah. So do you guys have any ideas? So it might seem a little tricky, but just think a little bit more. Like it's not actually that complicated. And guys, if you again, I'm reminding you guys, if you have any feedback and if any doubts, anything, please don't hesitate to ask. No, like, and I'll also be available after the session ends. I have no problem explaining doubts. But I just want you guys to understand what I'm explaining right now. So do you guys have any ideas on how do you divide these into 2 sets? It's kind of like it kind of doesn't make sense at the start, but you'll understand why. Yeah, okay, fine. I'm assuming no one could figure it out. Okay, so it's very stupid, but you just initialize. Let's just say you initialize long n sum is equals to n star by 4. Oh, give me a second, guys. Okay, so you can easily say that let's say we have a vector which we are pushing all the elements which form part of the first set into. So you can easily say that when we figure out one of the sets, the other set is obviously all the elements which are not in the set. So we just want to figure out one set where the sum of the elements is this. So this is a very stupid way, but it actually works. So what you do is, before I actually code it up, I'll explain it to you guys. What you do is, you iterate backwards from n to 1, and you just if the sum is greater than the number you're iterating through, you just add it to the set. So this is something, this is called the greed, like, okay, forget about that. Yeah, this is like very simple. You just iterate backwards, and if you have a number which is more than the, which is less than the, less than the sum, you just add it to your sum and decrease your sum by that specific amount. So let me code it up and explain it to you guys. So for I is equals to n, I is equals to greater than 1 and minus minus. But basically iterating through all n numbers, and this will be under the time constraint because n is 10 power 6. That it helps us, we can iterate in of n. And also guys, I forgot to tell you guys, but try to get familiar with time complexities and space complexities. I'll send that to the group after the session, but I'll be talking about them a lot more from next session. Anyways, we just, so if m sum is greater than or equal to I, we just do sum minus I and v dot push back I. So why does this work? So I don't want to prove it, but I think you can tell that by intuition. Like, you can tell that for a specific sum, there will be some elements, like, let's just say, how do I explain this? So if we're iterating backwards, we initially have five. We have. Let's assume n is 5. Okay. So we have 5, 4, 3, 2, 1. So yeah, 5, 4, 3, 2, 1. So this doesn't actually satisfy the answer. Like, it would output no here because 5 into 6 by 4 is not even. But forget about that. I'm just trying to see if this is how this works. So it would iterate from the back, and you can easily tell that if, like, obviously the answer exists. We know the answer exists. So we can easily tell that these elements all, like, they can add up to literally anything from all the way from 1 to what do we say? Like the 5, like the total sum of elements, 5 into 6 by 2, which is 15. So we can say that we can take all, like, some element from this, and we can make it represent any element from 1 to 15. Like, you can do this by just writing it down and just checking, but you can tell. Like, I don't want to prove it, but you can easily tell that. So that we use the same trick here and just push it back into this vector. But now they want us to output both the vectors, both the sets. So how do we do that? It's pretty simple. We just initialize another vector v1, and if this condition follows, it pushes into this vector, right? But if it doesn't follow, what do? We push it into the other vector. It's literally that simple. So this is like, if I write v comma v1, it's basically initializing two different vectors of int. So yeah, I forgot to define n. Let's just, and I'm pretty sure n star, and again I'll struggle with the overflow thing, so let's just use long because n is 10 power 5, right? Here it might get messed up. So sum, and let's this doesn't have to be int, but I'm just writing long int because I don't want to take a yeah. So now let's just output all the both the vectors. I just explained what v dot size was. It just returns the size of the element, so it makes it easier for us to iterate through. Vi, and we just output both the vectors. I'm just going to copy paste this for convenience, and change it into v1 and v. Yeah. So now this should work. So 7. Let's just type 7. Does it work? Do they want? Yeah. Yeah. I mean, the sum here is 356. one of the sets, 8 plus 6, 14, and 14. It does work. So we can tell that, yeah, it does work. So let me just copy paste it. I mean, this problem was kind of just guessing it, I guess, but you can prove it. It's not that bad, but yeah, I didn't. It's not exactly the best problem. Okay, we got some wrong answers. Did we mess up somewhere? Let's just look through first. Let's just try to look through our code to figure out if we did anything wrong. We took care of the overflow error, so that shouldn't be a problem. We output no. The problem is I forgot to output yes. That's yeah. It's kind of sad, but yeah, that was our problem. I'm pretty sure they want us to output yes and then the two sets, but I forgot to output yes. Yeah. I'm making all these stupid mistakes so that you guys don't have to do it in the future, guys. This should work. Okay. Okay, it didn't work. Oh shit, I forgot to save it. I yeah. Okay, I'm assuming. Okay, so let's this one is not related to yes. Let's just look at the test cases. Uh, okay, one more mistake I forgot to do was I forgot to output the size of the test cases. I mean test size sets. So which was a pretty big mistake. I forgot to output everything. Yeah, guys, just look at the output format before you start coding. I'm just doing this because I was explaining it to you guys, but that's still not an excuse. I kind of messed up, but let's just look at the other cases. Yeah, this should work. We can finally move on to the next question. And don't worry about submitting wrong core solutions, guys. It's doesn't matter. As long as you end up finding the actual correct solution, that's all that matters. Like it's pretty chill that way. So let's go into the next one. Bit strings. So your task is to calculate the number of bit strings of length n. For example, if n is equal to 3, the correct answer is 8 because the possible number of strings is 0, comma 0, comma. Yeah, so it's basically like all the possible bit strings with a bit string is basic. Let me explain what bit strings are. Bit strings are strings where each character can only be two things. It's either a 0 or a 1. So if it's size 3, that means we want a size 3 bit string where it's each character is either 0 or 1. So for n equals to 3, the total number of possible bit strings are only 8. We can tell by just looking. So they want us to output the total number of bit strings for each, for any n. And they told us to do it modulo. The reason they ask us to do it modulo this big number is because sometimes the answer can be so big that it's bigger than the range of long int as well. And to stop that, to avoid that, they ask us to do it modulo. Modulo is the percentage operator, which I explained. Like it's like the fraction like remainder part. So forget about the modulo operator for now. Let's try to figure out for n is equals to anything, what would be the answer. Forget about long int bounds and whatever. Can we just find the result? Do you guys have any ideas? This is a very easy question. I don't know why it's here, but yeah, 2 power n. It's as simple as that. This is more towards coding. I think more towards coding it, I would say, but that is also pretty simple. I don't know why it's here, but yeah, let's just code it up. So we just take an input and the range of n can be 10 power 6. So we can just do this in O of n. So long int sum is equals to 1. I'm initializing it at 1. I'll explain why. So we took our input, and we can say since it's 2 per n, we could use the power. Guys, one more thing I would recommend you to not use is, I'm pretty sure guys, most of you would be familiar with the math library in which you have the power function, which is like, a comma b means it would be a power b. Don't use this. This is kind of bad because this returns. This is not always accurate. I'm not going to go into why it's always not always accurate, but try to find alternatives. This is like, I would recommend against using it because it will mess up your answer. So we're not going to use power of a comma b here, and let's just so let me code it up and explain it. So we can write sum equals to sum star 2. Do you understand why this is 2 power n? We're iterating through n times. I is equal to 0 till n means it goes I is equal to 0 till n minus 1. So that's total. If you count that, that's n times. So we're basically just writing sum is like, we're just multiplying it n times. This is like a different way to do that. Not always working, not always helps, but for this problem it helps. And one more thing is, we have to do modulo 10 power 9 plus 7. So how do we do that? So every time we multiply it by 2, we just modulo it 10 power 9. I'm just going to 10 power 9 is 9 digits, right? So 1 2 3 4 5 6 7 8. Yeah, so this should be 10 power 9. Hopefully that is. Let me just cross check. It does. Yeah, it looks like it is. Okay. So it's a pretty simple problem. Like, it took me like 4 lines, I guess. So let's just check it. Yeah, it works. Hype. Let me just submit this. I don't know why I did this. This problem was kind of a waste of time. Guys, the introductory session is like, the first section is actually very simple. Don't assume the other sections are like this, because they're a huge pain in the ass. Yeah, warning you guys. But even the ending problems of this is pretty challenging, I would say. So trailing zeros. This is a cool problem, I would say. So your task is to calculate the number of trailing zeros in the factorial n. For example, and 20 factorial is this big number, and it has 4 trailing zeros. Trailing zeros is the zeros at the end of the number when you actually find the factorial of the number. So they just want to know for a specific n factorial, how many trailing zeros would it have. So is there a way to do this? It seems tricky, but it's actually very simple. Is there a way to find the number of trailing zeros in this number? Do you guys have any ideas? I'll give hints if you guys can't figure it out, but fine. Yeah, I didn't read the chat before, but yeah, Callisto, you're right. You just do sum square 2, and you have to figure out modulo that. Yeah, find the exponent of 5 since it'll be lesser. That's pretty correct. Yeah, that's correct. We just need to find the powers of 2 and 5, and I guess there's a formula for that. Yeah, I mean, you don't need to find the powers of 2 because, like Pranav said, find the exponent of 5, because you can easily say that the number of 2's after you find, if you like, let's say you factorize the final number you find, the number of 2's in that number would be a lot more than the number of 5's, because you find a 2 every alternate number. 5 is every 5 numbers, obviously. Yeah, and the minimum power is the answer. Powers of, how do you calculate the powers of 5? Okay, you guys are right, it's calculating the powers of 5 itself, but I'm not going to. So you could calculate the number of 5's. It's pretty simple, right? So you just take it as you just take input in n, and in I is equals to 1. If it's n factorial, it goes all the way from 1 to n, right? 1 to n and 1 to n, and you just f n percentage 5. Oh, we could do while length percentage 5 because something like 25 would give us two fives, not one five. So we could just do, wait, let me find out what long int sum is equal to 0. So we would just do sum plus plus. Every time a number is divisible by 5, okay, wait, I we can't modify I here, so we need one more character, C. Let's just say find C. If you modify, the reason I'm, wait, let me code it out. The reason I'm assigning C to I is because if you if you modify I while the for loop is running, the for loop will get messed up, right? So let's assume I is at 5 and you do I percentage 5 and you divide it by 5, then it would go back to 1 and it would be in like a infinite loop. So you don't want to mess with the, you don't want to change I inside the for loop. You should, the only time you should be changing is this I plus plus. So now this should work. Yeah, this should work, but this is not the most fastest way to do this because n is 10 power 9 here. So for some, like, for I'm not going to explain it very like, in depth, but 10 power 9, when n is 10 power 9, you can't find the linear solution will be too slow. You'll get time limited exceeded. For to prove it, let me just code it. So for 20 it should output 5, I guess. That should be correct. So okay, wait, I messed up somewhere. I forgot to take input. Happens. Classic mistake, I guess. Yeah. So 28, what? C percentage 5 is equals to 0. Yeah, that's like is equals to 0 means it's like it's divisible by 5. Yeah, so it's 4. So let me just submit it. So this is just to show you guys that when n is 10 power 9, linear solutions don't work. Like you can't, even a for loop from 0 to n is too slow. That's when you get time limit exceeded. So by the next time, please try to be familiar with time complexity so that I can explain, I can just tell in terms of like O of n or whatever. So you get time limited exceeded. So do you guys have any ideas of, yeah, we can log to the base 5 for finding the exponent. Yeah, that's pretty correct. But can you be more specific? What do you mean log to the base 5? Like, uh, can you do it without using log? Like, guys, try to, like, the reason told you to avoid power operator is uh, because this returns a float value. Any functions which deal with float values. So what are float values? Before I explain this, I'll explain what are float values. So till now we are only using integers. What if we want to have a variable like a value like 2.45 or something? What if we want to have, have this value 2.45? So for that we use something called float. Float n is equals to 2.45 and this would work. But for integers, yeah, so these functions are made for like floating point values. For integers, sometimes they're inaccurate. So I would recommend you guys to avoid all those functions. But log, yeah, log does work, I guess. I don't, for this we can use log, I think. But let me just see if any other people have more ideas. Let me, yeah. Okay. Yeah, That makes sense, I guess. Let me look at it. It is 5. Hmm. You're just basically finding number of fives and 25s, adding, yeah. So what his code is doing is just calculating the number of all the numbers which are divisible by 5, and then again calculating the number of numbers which are divisible by 25 and 125, because you have to recalculate the number of numbers which are divisible by 25, because the 5 one would have included the 25, but it would have included it only once. But 25 obviously gives you two 5 divisors, right? So you have to again recalculate the 25 thing and add it once. Yeah, that's pretty. That works. That's what I was looking for. So I'll do it slightly differently though. I'll teach you guys something called recursion. So I'm sure you guys are familiar with functions, right? Because we'll be using these a lot. Uh, yeah. Uh, let's just say a return value of return. I mean, long int solve int. Okay, so let me explain for those who are not familiar with functions. Let me just explain what functions are. Functions are basically just usable code. Okay, so usually when people want to call functions again and again and again, you just don't want to type the same code twice, thrice, or 4 times, right? You just don't want to keep doing that. So you just call of, like, initial, like, make a function here. So this function can be accessed by like this. Let's say int. So this is the return value of the function. Like, it returns when you call this function, you give it some number n, and it returns a long int variable. And this is what happens to the function inside. Like, this is the code inside the function that runs every time you give it n. It goes through, like, it's basically like the main function. Like, even main is a function. Like, this is always run at the start of the program. So anyways, yeah, so let's assume we give the value 5, okay? So actually, let's assume we give the value 3. If n is equals to less than 3, it returns 0. So this terminates. It's legit as simple as that. So we give it 3, it runs through n is less than 5, we just got true, so it goes through this statement. So now let's give it something, let's give it n is equals to 5. So if n is equals to 5, this if statement is, it doesn't go through this if statement, because this thing is false, right? N is not less than equal to 5. So we ignore that code and we go to the thing. This is another return function. So here n by 5 plus solve n by 5. So here 5 by 5, 1 plus solve 1, and 5 by 5 would be 1, right? So we are calling the function one more time. So this is something called recursion. So recursion is when you call a function itself. It's very convenient. So I would recommend you guys, like, learn upon it if you don't understand what I just said, because it is kind of complicated for people who just started programming. I found it very complicated, at least. So just look up some videos on recursion. It's it's very easy after you learn what it means, and you'll start using it more and more. So now let's go to understanding why this actually works. So yeah, so what are we doing here? So if you're giving 20, let's just run it through. Is this actually correct? Does this actually work? So if you give 20, it returns 4 plus solve of 4. Solve of 4 is obviously 0. So what does the solve function return? It obviously returns the number of trailing zeros for some specific number. So Why is this true? Why is a number trailing zeros of n is equals to n by 5 plus like trailing zeros of n by 5? Can any of you like figure it out? Like I just want to know if you guys are familiar with recursion. And Pranav, your code is actually 100% correct. I just want to explain recursion, so this is why I didn't use your example. Mm, I mean, we're kind of out of time, so I'll just, yeah, I'll just give you guys 1 minute, I guess. Okay. Mm. So, okay, I mean, I can't explain it today, but I'll give you guys I'll give you these, I'll give this as homework. So, guys, your homework would be a number spiral, two knights, uh, trailing zeros, and coin points. Let me just look at it. Yeah, this is a pretty good question. I wanted to do this today itself, but it's fine. So your coin. I think parent room. Yeah, this is also a good question. Gray code. I think I'll skip this one. And Tower of Hanoi. Yeah, this is the last question we'll do. Yeah, so guys, you have. I'll give you guys 5 questions as homework. These questions are actually kind of challenging, but I'll go through these the next session, most of them at least. So, one, two, three, four, five. Actually, six of them. I'll send them in the WhatsApp chat. I think that's it. I wanted to do a lot more questions, but unfortunately, I had to explain a lot of, you know, new like a lot of new C++. So it's fine. I'll take another session in like two days, I guess. Maybe day after tomorrow or one more. Like I don't know. I'll give you guys some homework as well. So, any questions, guys? Any of you have any questions? Will after the just to let you know after the the 2 days, 2 days later I'll take a session, right? After that session we'll be done with introductory problems. I think we'll start with sorting and searching, and that'll be kind of like that'll be a little bit more complicated as well, so it'll be kind of fun to do as well. So I guess you guys can leave if you don't have any questions. Thank you.